Hello viewers, welcome to my channel Maths with VTC. Today's class we are going to deal with algebraic methods of solving a pair of linear equations. In previous classes we studied how to solve a pair of linear equations graphically. In graphical method we have one drawback. At the point of intersection, finding the value of x and the value of y is difficult in graphical method. Suppose the values of x and y are integral, then it is easy. If they are fractions, then it would be tough to find the values of x and y. So, such a case, algebraic methods of solving a pair of linear equations will be so easy. Let us see the procedure involved in algebraic methods of solving a pair of linear equations. Find the value of one variable, say y, in terms of the other variable, that is x, from either equation, whichever is convenient. Second step, substitute this value of y in the other equation and reduce it to an equation in one variable, that is in terms of x, which can be solved. Sometimes you can get statements with no variables. If this statement is true, you can conclude that the pair of linear equations has infinitely many solutions. If the statement is false, then the pair of linear equations is inconsistent. And step 3. Substitute the value of x obtained in step 2 in the equation used in step 1 to obtain the value of the other variable. So these are the 3 steps involved in algebraic method of solving a pair of linear equations. It is so simple. You will realize it when I solve problems. Consider the example 4. Solve the following pair of equations by substitution method. 7x minus 15y is equal to 2, equation 1. X plus 2y is equal to 3, equation 2. Obviously, equation 2 is simple. So, from the equation 2, you can find the value of x, which is equal to 3 minus 2y. So, first step is over. Next, substituting this value of x in equation 1, we get 7 into 3 minus 2y minus 15y is equal to 2. Or 21 minus 14y minus 15y is equal to 2. When you reduce this, you get y is equal to 19 by 29. So, second step is also over. Now, we go to third step. Substituting the value of y in equation 3, we get x is equal to 3 minus 2 into 19 by 29, which is equal to 3 minus 38 by 29, which is equal to 49 by 29. Therefore, the solution is x is equal to 49 by 29 and y is equal to 19 by 29. So, it is very simple. From one equation, you find the value of x. You put this value of x in the other equation, you get value of y. Then again, you can obtain the value of x by substituting the value of y. So, it is very simple. You can verify this answer by substituting the values of x and y in equations 1 and 2. Now, example 5. Solve the following question. Aftab tells his daughter, 7 years ago, I was 7 times as old as you were then. Also, 3 years from now, I shall be 3 times as old as you will be. Represent the situation algebraically and solve by the method of substitution. So, we have to find the age of Aftab and his daughter. So, let S and T be the ages of Aftab and his daughter respectively. S is the age of Aftab, T is the age of his daughter. Then the pair of linear equations are S minus 7 is equal to 7 times T minus 7. 7 years before. Therefore, S minus 7. T minus 7. What is the relationship? S minus 7 is equal to 7 times T minus 7. When you simplify, you get s minus 70 plus 42 is equal to 0. You call that as equation 1. And 3 years hence, that means after 3 years. After 3 years, Aftab age will be s plus 3 and her daughter age will be t plus 3. What is the relationship? S plus 3 is equal to 3 times t plus 3. When you simplify, you get s minus 3t minus 6 is equal to 0 and you call this as equation 2. Now you have to find value of one variable. You consider equation 2. From equation 2, s is equal to 3t plus 6. Because equation 2 seems to be simple to find the value of s. So, I write s is equal to 3t plus 6 and I am going to put this value in equation 1. So, I get 3t plus 6 minus 70 plus 42 is equal to 0. Therefore, t is equal to 12. Now, putting this value in equation 1, we get s is equal to 42. Hence, Aftab and his daughter age are 42 and 12 respectively. So, that is the solution. Very simple. You have to construct the equations and then you can easily solve by method of substitution. Now, example 6. In a shop, the cost of 2 pencils and 3 erasers is rupees 19 and the cost of 4 pencils and 6 erasers is rupees 18. Find the cost of each pencil and each eraser. So, we have to find the cost of pencil and eraser. So, we take x and y be the cost of a pencil and eraser respectively. Then, the pair of linear equations that represent the situations is 2x plus 3y is equal to 9 because 2 pencils and 3 erasers cost rupees 9 and 4x plus 6y is equal to 18. From equation 1 we get x is equal to 9 minus 3y divided by 2. We substitute this value of x in equation 2 and we get 4 into 9 minus 3y divided by 2 plus 6y is equal to 18. When you simplify, you get 18 is equal to 18, which is a true statement. So, what do you infer from this? The given pair of equations has infinitely many solutions. We cannot give any specific solution for x and y. So, when you look at the equations 1 and 2, you can realize that both are same. When you multiply equation 1 by 2, you get the second equation. Therefore, we are given only one equation. Therefore, the given pair of equations has infinitely many solutions. Now, we move on to example 4. Two rails are represented by the equations x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 is equal to 0. Will the rails cross each other? Suppose the rails cross each other, what will happen? The straight lines x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0 will intersect at a point. Let us check whether they intersect or not. So, we take x plus 2y minus 4 equal to 0 as equation number 1 and 2x plus 4y minus 12 equal to 0 as equation number 2. Now, from equation 1, we get x is equal to 4 minus 2y because equation 1 seems to be simple to find the value of x. X is equal to 4 minus 2y. Now, we substitute this value of x in equation number 2. So, we get 2 times 4 minus 2y plus 4y minus 12 is equal to 0. When you simplify, you get minus 4 is equal to 0, which is a false statement. Therefore, the equations do not have a common solution. So, the rails will not cross each other. Now, exercise 3.2. First problem, solve the following pair of linear equations by substitution method. X plus y equal to 14, x minus y is equal to 4. So, we take x plus y equal to 14 as equation number 1. And x minus y is equal to 4 as equation number 2. From equation 2, you find the value of x. Obviously, x is equal to y plus 4. So, you put this value of x in equation number 1, we get y is equal to 5. So, again substituting this value of y in equation 3, we get x is equal to 5 plus 4 which is equal to 9. So, we have solved the pair of linear equations. So, solution is x is equal to 9, y is equal to 5. Simple. Now, second problem, s minus t equal to 3, s divided by 3 plus t divided by 2 is equal to 6. So, you take equation 1 as s minus t equal to 3 and equation 2 as s by 3 plus t by 2 is equal to 6. From equation 1, s is equal to t plus 3. Putting this value of s in equation 2, we get t plus 3 divided by 3 plus t divided by 2 equal to 6. When you simplify, you get t equal to 6. Putting this value of t equal to 6 in equation number 3, you get s is equal to 6 plus 3 which is equal to 9. Therefore, the solution is s is equal to 9, t equal to 6. So, it is very simple. Using one equation, you find value of one variable in terms of the other variable. You substitute this value in another equation, you will get a value for the second variable. Again, you substitute the resulting value in equation 3, you get the answer. It's very simple to find a solution of a pair of linear equations by substitution method than graphical method. Problem number 3. 3x minus y equal to 3, 9x minus 3y is equal to 9. So you call 3x minus y equal to 3 as equation number 1 and 9x minus 3y equal to 9 as equation number 2. So from equation 1, y is equal to 3x minus 3. Substituting this value of y in equation 2, we get 9x minus 9x plus 9 is equal to 9. Therefore, 9 equal to 9. This statement is true for all values of y. Therefore, we cannot obtain a specific value of x. That means what? The given equations are the same. The given two equations have infinitely many solutions. You look at the equations 3x minus y equal to 3. Second equation can be obtained simply multiplying the first equation by 3. Therefore, both are one and the same. Fourth problem. 0.2x plus 0.3y is equal to 1.3. 0.4x plus 0.5y is equal to 2.3. In order to avoid decimal places, I multiply both the equations both sides by 10. So I get 2x plus 3y is equal to 13 as equation number 1 and 4x plus 5y is equal to 23 as equation number 2. From equation 1, I get the value of x, which is equal to 13 minus 3y divided by 2. Substituting this value of x in equation 2, I get 4 into 13 minus 3y divided by 2 plus 5y is equal to 23. When you simplify, you get to y equal to 3. Now, substituting this value of y in equation 3, we get x is equal to 2. Therefore, the solution of the given pair of linear equations is x is equal to 2, y equal to 3. It is very simple. Equation 5. Root 2x plus root 3y equal to 0. Root 3x minus root 8y is equal to 0. So you call root 2x plus root 3y equal to 0 as equation number 1 and root 3x minus root 8y equal to 0 as equation number 2. From equation 2, we get x is equal to root 8 divided by root 3 into y. Substituting this value of x in equation number 1, we get root 2 into root 8 divided by root 3y plus root 3y is equal to 0. You multiply both sides by root 3. We get root 2 into root 8y plus root 3 into root 3y is equal to 0. Therefore, y is equal to 0. Substituting this value of y in equation number 3, you get x is equal to 0. Therefore, the solution is x is equal to 0, y is equal to 0. Sixth problem. 3x divided by 2 minus 5y divided by 3 equal to minus 2. X divided by 3 plus y divided by 2 equal to 13 by 6. So in order to avoid fractions, I multiply both the equations by 6. So I get 9x minus 10y is equal to minus 12, which is equation number 1. And 2x plus 3y is equal to 13, which is equation number 2. So from equation 2, I get x is equal to 13 minus 3y divided by 2. Substitute this value of x in equation number 1. I get 9 into 13 minus 3y divided by 2 minus 10y is equal to minus 12. When you simplify, you get y is equal to 3. Putting this value of y equal to 3 in equation 3, I get x is equal to 2. Therefore, the solution of the given pair of linear equations is x is equal to 2, y equal to 3. Second problem. Solve 2x plus 3y is equal to 11 and 2x minus 4y equal to minus 24. And hence find the value of m for which y equal to mx plus 3. So first we have to solve the given two equations. So I take 2x plus 3y equal to 11 as equation number 1 and 2x minus 4y equal to minus 24 as equation number 2. So from equation 2, x is equal to 4y minus 24 divided by 2. Substituting this value of x in equation 1, I get 2 into 4y minus 24 divided by 2 plus 3y is equal to 11. After simplifying this, I get y equal to 5. So when you substitute y equal to 5 in equation number 3, I get x is equal to minus 2. Hence the solution is x is equal to minus 2, y is equal to 5. Now we have to find the value of m. So you substitute the values of x and y in the equation y is equal to mx plus 3. Therefore, m becomes minus 1 because 5 equal to minus 2m plus 3. Therefore, m is equal to minus 1. Hence the solution. Next problem. Form the pair of linear equations for the following problems and find their solution by substitution method. The difference between two numbers is 26 and one number is 3 times the other. Find them. So we have to find two numbers. So naturally we take x and y are those two numbers with the condition that x is greater than y. Then we are given difference is 26. Therefore, x minus y is equal to 26 and one number is thrice the other number. We have taken x as a large number. Therefore, x is equal to 3y. Now, putting x is equal to 3y in equation 1, we get y is equal to 13. If you put this value y equal to 13 in equation 2, you get x is equal to 39. Hence, the solution is x is equal to 39, y is equal to 13. Very simple. You have to construct the pair of linear equations and then you have to solve. Next problem. The larger of two supplementary angles exceeds the smaller by 18 degrees. Find them. Supplementary angles. You remember the definition. Sum of the two angles is equal to 180. Then one angle is supplementary angle of the other. Let the two supplementary angles be x and y, and x be the greater angle. We assume like this. Then x plus y is equal to 180 and x minus y is equal to 18 because we have assumed x is greater angle. So from the second equation, x is equal to 18 plus y. If you put this value of x in equation 1, we get y is equal to 81. So putting this value of y in 2, we get x is equal to 99. Therefore, the solution is x is equal to 99 and y is equal to 81. So sum is 180 and the difference is 18. You can easily verify this also. Next problem. The coach of a cricket team buys 7 bats and 6 balls for rupees 3,800. Later, she buys 3 bats and 5 balls for rupees 1,750. Find the cost of each bat and each ball. So what we do? We take x is the cost of a bat and y is the cost of a ball. Now we form the linear equations. 7x plus 6y is equal to 3,800. You call that as equation 1. 3x plus 5y is equal to 1,750. You call that as equation number 2. From equation 2, what is x? X is equal to 1,750 minus 5y divided by 3. So putting this value of x in equation 1, we get 7 into 1,750 minus 5y divided by 3 plus 6y is equal to 3,800. When you simplify, you get y is equal to 50. Now you put this value of y is equal to 50 in equation 3, we get x is equal to 500. Now we got the solution. The cost of a ball, x is equal to rupees 500 and the cost of a bat, y is equal to rupees 50. Fourth problem. The taxi charges in a city consist of a fixed charge together with the charge for the distance covered. For a distance of 10 km, the charge paid is rupees 105 and for a journey of 15 km, the charge paid is rupees 155. What are the fixed charges and the charge per kilometer? How much does a person have to pay for traveling a distance of 25 km? Read the problem carefully. We have to find the fixed charge and the charge per kilometer. So x be the fixed cost and y be the cost of per kilometer. So you assume that x is the fixed cost and y is the cost per kilometer. So from the first statement, for 10 kilometers, charge is rupees 105. That includes fixed charge and the charge per kilometer. Therefore, it is x plus 10y which is equal to 105. That is equation number 1. X plus 15y is equal to 155. That is equation number 2. Now from equation 1, we get x is equal to 105 minus 10y. We substitute this value in equation number 2. We get y is equal to 10. If you put this value in equation 3, you get x is equal to 105 minus 100, which is equal to 5. Hence, the fixed cost is rupees 5 and the cost per kilometer is rupees 10. So for traveling distance of 25 kilometers, the total cost is equal to fixed cost plus a charge for 25 kilometers. Therefore, 5 plus 25 into 10 is equal to 5 plus 250 is equal to rupees 255. Fifth problem. A fraction becomes 9 divided by 11 if 2 is added to both the numerator and the denominator. If 3 is added to both the numerator and the denominator, it becomes 5 by 6. Find the fraction. So a fraction has a numerator and a denominator. We take x as the numerator and y as the denominator. So what we are given, x plus 2 divided by y plus 2 is equal to 9 by 11. When you reduce it, you get 11x minus 9y plus 4 equal to 0. That is equation number 1. Also, x plus 3 divided by y plus 3 is equal to 5 by 6. When you reduce it, you get 6x minus 5y plus 3 equal to 0. You call this as equation number 2. From equation 2, x is equal to 5y minus 3 divided by 6. Now, substituting this value of x in 1, we get 55y minus 33 minus 54y plus 24 is equal to 0. When you simplify, you get y is equal to 9. We can put this value in equation 3 to get the value of x. So when you put y is equal to 9 in equation 3, you get x is equal to 45 minus 3 divided by 6, which is equal to 42 divided by 6, which is equal to 7. Hence, the fraction is 7 divided by 9. You can easily verify this also. Sixth problem. 5 years hence, the age of Jacob will be 3 times that of his son. 5 years ago, Jacob's age was 7 times that of his son. What are their present ages? So their present ages are required. Let x be the age of Jacob and y be the present age of his son. Now, what we are given, x plus 5 is equal to 3 times y plus 5. That is, after 5 years, their ages will be x plus 5 and y plus 5, but father's age is 3 times that of his son. Therefore, when you put it to the equation form, x plus 5 is equal to 3 into y plus 5, or x minus 3y minus 10 equal to 0. Second relationship, 5 years ago, their ages should be x minus 5, y minus 5. The relationship is x minus 5 is equal to 7 times y minus 5. When you reduce it, you get x minus 7y plus 30 is equal to 0. From equation 1, x is equal to 3y plus 10. Substituting this value of x in equation 2, we get 3y plus 10 minus 7y plus 30 is equal to 0. After simplification, we get y is equal to 10. Substituting this value of y in equation 3, we get x is equal to 40. Therefore, the age of Jacob is 40 and his son's age is 10. So, these are their present ages. Thank you for watching my video.